Hello, hello everyone. Thank you for joining us for this session, our webinar in collaboration with Planet and Esri China, Hong Kong. Today webinar, we are going to talk about geospatial analysis of satellite imagery with live demo by using the Esri platform. I'll be the first speaker. My name is Baizura Alidin. I'm the pre-sales engineer at Planet, which is covering the Asia Pacific region, and also based in Malaysia. And after the next host will be covered by Esri team, Kevin Chan, then Imagery, and also Mr. Felix Leong. And if you have any question during our session, please put it in the Q&A box. Then we will cover or we will answer those questions during the Q&A session. Okay, let's get started. So for today's over about, I think about 20 minutes, I have 4 agenda items to share with you. Firstly, I'm going to talk about Planet overview as a company. Then I'm going to talk about Planet satellite constellation, introduction of our satellite. Then I'm going to move on Planet solution. In these 20 minutes, I might not able to share the entire solution that we have right now in Planet, but I'm going to cover or to highlight the most core solution, which is Planet monitoring. And then last but not least, we're going to do, I'm going to talk about Planet delivery, how user or customer can access to our data and imagery. So here at Planet, we are driven by the notion that no matter what your industry or role or geography, you can't fix what you can't see. Why? As we know, human and environmental activity on Earth change at varying cadence of days, weeks, and months, posing a variety of challenge in many industries. So the very simple message that I would like to get across today: you can't fix what you can't see. And just to clarify, this doesn't just relate to initiative spatial resolution. For example, the size of the pixel or how clear the image in terms of detail, but also the cadence of that information or the temporal resolution, which is how often those image or data and insights are available. The traditional approach in satellite imagery in monitoring the Earth is falling short. At high level, we have found that most of the organization, they don't have data that cover the area that they care about, which is the coverage is limited. They don't have it at the right revisit of frequency. The data is difficult to access, or is simply too difficult to extract meaning out of data itself. So our mission in Planet has remained the same since Planet was founded in 2010, which is to image the entire world every day and make that information visible, accessible, and actionable to anyone. To do this, we operate the largest constellation of Earth imaging satellite in human history, and is providing a radically new data set that can inform us regularly on our changing planet. While Planet is very much a data as a service company, we working with our partner network or analytic capable clients that can answer the real world problem. For example, how many houses have been built in Pakistan over a certain time period, and this is actually the real actionable outputs. So the new approach that Planet provide in geospatial data is at the speed of change, equipping user with the data necessary for making informed, timely decision. Our approach, high frequency, global coverage. So we monitor your world with the most up-to-date global satellite data, which we capture every day. And We also prepare or produce analysis-ready data that where user or customer can focus the investment on solving core problem with clean, consistent, and harmonized data. And also the way how we make this data available to user and the customer by using the modern APIs and cloud architecture. So let's talk about our satellite. So our fleet today, on the left one, we have over about more than 200 PlanetScope DAF satellite. It is our medium resolution PlanetScope DAF satellite, which is fly in large constellation to map the Earth's landmass every day at about 3 to 5 meter resolution. And we have 8 spectral bands right now with PlanetScope, which is coastal blue, blue, green 1, green 2, yellow, red, reddish, and near-infrared bands. And on the right, we have 21 high-resolution Skyset satellite. Right now, we have in orbit, provide responsive tasking multiple times a day at 50 centimeter resolution. So this combination of different satellite with different sensor allow us to detect change in lower or medium resolution, and then we can enhance or zoom in by tasking follow-up observation with the higher resolution satellite Skyset. And for the Skyset, we have 4 bands, which is the visible band, red, green, blue, and also we have the panoramtic band and also near-infrared bands. Okay, now I'm going to play an animation video for all the users to see how actually we operate our satellite. The first constellation, which is I mentioned earlier, is our PlanetScope satellite. Is always on, and we cover broad area monitoring, cover the Earth landmass at about 3 meter resolution. We have right now, previously we have 4 bands, but right now we have 8 bands. And on the right one, we have 21 Planet Skyset satellite. Is more custom targeted or tasking satellite at 50 centimeter resolution. We have RGB, near-infrared, and panoramtic bands. We have the first 15 Skyset satellite is at sun synchronous orbit at about 98 degrees. And we have Skyset number 16 to 21 at the inclined orbit. This is how actually animation, how our satellite works in the space. So now we are going to shift. I'm going to talk about the capability from our satellite. These 2 satellite constellation, we actually have the capability to do a high frequency monitoring because we have the daily, and also we have 21 Skyset satellite that can do multiple revisit in a day. And we are doing this global coverage, broad area monitoring at scale. We have high resolution with Skyset, and we also provide a very efficient access, which is with the modern API and also Gis Integration. So on the Planet solution, these are the 4 core products, which is Planet Monitoring, Planet Tasking, Planet Basement, and also Planet Analytic Feeds. For today's session, I'm going to cover Planet Monitoring because we have a limited time. But just a short introduction on the Planet Basement is actually a mosaic product because we collect daily imagery with our medium resolution PlanetScope. We also produce a mosaic or basement product where we select the best imagery of PlanetScope and then we produce a monthly and quarterly basement. And then we have Planet Tasking, which is more on Skyset satellite capability to do a tasking. And also because we have like a lot of imagery and data, we also do have some Planet Analytic feeds such as building detection, road detection, and also a vessel detection. Okay, now let's move on to Planet Monitoring. Under the Planet Monitoring, we have 2 offerings, which is with the PlanetScope constellation and also Skyset constellation. The first one, PlanetScope Monitoring, just recap on the PlanetScope. We have more than 200 satellites and we have 8 spectral bands right now with our latest generation super DAF satellite. I'm going to talk a little bit more later about these 8 bands. And these are the PlanetScope imagery product, where actually we publish the produce the basic scene, ortho scene, and ortho tile, where it depends on the it's designed actually for different user with different capability. For example, for the basic scene, if the customer or user has the capability to image and processing to do the geometric correction themselves, they can use the basic scene and do the processing themselves. But also we produce the ortho scene and ortho tile, which is designed for user who want rectify and correct the imagery but want to do a manual tile for their specification for the ortho scene. And for ortho tile, it's designed for user who want rectify and correct the imagery in tile format, so there is no compositing involved. Here are some sample of PlanetScope imagery. The first one is an image of Shanghai, China, captured on April 30, 2022. This is by using our Super DAF satellite. And this one, an image of Randonia, Brazil on September 5th, 2018. We can see a bushfire here in this image. And yeah, an example of the new PlanetScope imagery, which is from our latest PlanetScope Super DAF satellite. This is over the Shark Bay, Australia on April 22nd. And this one here is PlanetScope imagery view in the false color composite. And this one as view as in normalized different vegetation index by using the 4-band red band and also the RGB band and also near infrared band. And I would like to update all the participants today about the latest news on PlanetScope, which is we do release this new PlanetScope starting March 1st this year. This is what you need to know because we have our latest generation of PlanetScope satellite. We call it Super DAF, and this Super DAF is the latest generation, and it has the capability to do 8 spectral bands. The additional bands in top of the standard red, green, blue in your thread is are coastal blue, red edge, yellow, and also the green too. PlanetScope 8-band imagery right now, we have the capacity. We already achieved near daily global frequency. It's available right now in all our platform, which is including API, and also it can be accessed by using our Planet Explorer and also integration with the GIS application. And it's calibrated to Sentinel-2 as opposed to the previous one to Rapid Eye, our old satellite constellation. And we also made some key quality improvement to improve the consistency of reliability of the data. So here are the detail of PlanetScope spectral response for each of the 8 bands: coastal blue, blue, green 1, green 2, yellow, red, reddish, and near infrared. And as you can see here, the first on top is actually referred to the Sentinel-A spectral response. And these are the 3 PlanetScope with different generation. The first one on top is our first group of DAF Classic. We call it DAF Classic, DAF R, and the latest one is Super DAF. As you can see on the Super DAF itself, the spectral response is actually closer to the Sentinel-2A as compared to the DAF Classic and DAF R. So here some recommendation on how these 4 more bands are able to assist or what kind of use case that can benefit from this additional 4 bands that we have right now. These are the details here. And I would like to highlight on the red edge band, which is good for the land cover or crop tree classification, early detection of vegetation stress, vegetation determination, and also can also be used for water quality, turbidity, sediment, and vegetation and coral mapping. Let's move on to Skyset monitoring. So with Skyset, we have 21 satellites. The GST is 0.65 meter resolution, but we also produce the ortho products of Skyset Imagery at 0.5 meter. And we have the capacity to capture about 500,000 kilometers square per day. And we have spectral band, red, green, blue, panchromatic, and also near-infrared bands. For Skyset monitoring, we guarantee collection at established revisit interval, where user or customer of Skyset, they can choose collection frequency, which is sub-daily, daily, weekly, monthly, or quarterly, or simply probably just one-time tasking. But this all subject to feasibility study, and in case there's an unfulfilled interval, we are given back to the customer as future tasking requests. But I just want to highlight normally for sub-daily or daily tasking, there is no cloud cover guarantee, as we know for optical satellite imagery, it's still depending on the weather, and we can't really control the weather. So for sub-daily, daily, there's no cloud cover guarantee. And Planet's tasking is we can do a rapid revisit, global intelligence, where for the rapid revisit, we can do average about 5 to 10 times per day, depending on the location itself and subject to feasibility study. And we have the capacity to get visibility into location across the globe to schedule analysis. We have low latency, which is we publish the image of the Skyset less than 10 hours from the collection to delivery. There is also an option where we can expedite the delivery between 2 to 3 hours. And it's not just imaging the image. We have different capability with Planet tasking, which is we can do or capture video, stereo image, and also off-nadir imaging. And transparency and ease of use is automatic order management and tasking, where actually we have this tasking platform. We call it tasking dashboard, where user or customer can actually place an order of Skyset by themselves. So Planet tasking, image any point on Earth at 50 centimeter resolution. On-demand collection, we normally do a collection at 15%, less than 50% cloud cover. With cadence can be chosen from monthly, weekly, daily, or sub-daily collection. And we also have the archive or historical data with over the 10 million square kilometer of Skyset. And these are the Skyset imagery products, where we publish the basic scene. We also process and publish the ortho scene and also Skyset collab. Here some example of Skyset imagery of China in Nanxiong. And this one, another example of Skyset in Peru in the forest. And as we can see here, this is actually a logging road. Can see there's if you can see here, this small detail here, there's some trucks or lorry that moving in this logging road. And comprehensive coverage, you also can pair both PlanetScope and Skyset for monitoring at multiple resolution. As because we have two different satellite constellation with different sensor, actually user or customer can benefit by using like this tool. For example, you can monitor or detect change with PlanetScope, and whenever you need to see detail, you can use high resolution Skyset to see more details. As this is an example here, the first on the left is image from PlanetScope, and then we task Skyset to see details what changing on this area here. This is the bigger picture of it, of a Skyset imagery for this area. And lastly is planet delivery, how actually we deliver the data and the imagery to our customer. And we have this Planet platform. It's fully automated imagery processing so that it can save time with imagery corrected for a variety of factor analysis ready without costly post-processing or manual intervention. But I would like to highlight we still produce the basic scene. So customer who has the capability to process them in-house, they can still access and get this raw imagery. And everything is cloud-based access because we want to deliver at speed and scale. So which is cloud-based is the best to do this. And we have API first integration and download. User can use API to download and programmatically search and download from our catalog with Planet's API built on accepted REST, JSON, and HTTP standard. Delivery option. As mentioned, we have Planet API. We also have Planet Explorer, our web-based platform where customer can just browse and view the imagery, and also they can download the imagery using our platform. We also have the integration with GIS platform with Esri ArcGIS and also QGIS, and we have FWMTS services available as well. So Planet Explorer, as mentioned, is our web platform. You can use to search it for imagery, you can stream, you can do some comparison by using this platform, image comparison, and you can analyze the imagery, take a measurement on the map, comparing image side by side, and also apply some indices and visualization, and also to download a full resolution image. For Planet integration, right now we have integration with Esri, ArcGIS Pro, and we also have integration with QGIS and also Google Earth Engine. I would like to highlight the Esri ArcGIS Pro because today's session is with Esri. As it's actually similar like how user or customer can access our imagery on our platform, where you can access to Planet Scope imagery, Skyset imagery, depending on which image that you purchase or subscribe, and also Planet Base Map within the ArcGIS Pro. And then you can pull the imagery. We also made image from Landsat and Sentinel available, and you can easily pull this into ArcGIS platform, and straight away you can perform additional operation on top of the imagery using ArcGIS Pro, such as image comparison, object detection, and geostatistical analysis, which will be covered later from the next session. How it works: you can access, search, and download Planet imagery in ArcGIS Pro. And I would like to have to highlight we have latest updates on integration, because recently we just published the Planet Scope Advanced. So if you're existing user or if you're currently running on trial Planet trial, you actually can use to your integration to the latest version of ArcGIS Pro in version 2.2 in order to have access this Planet Scope Advanced. Updates to GIS integration, as we already published the app band data, the previous PS Scene 3 band and PS Scene 4 band they are no longer represented in the UI. You can only search for PS Scene. We change it to PS Scene, and you also can search imagery or filter the search imagery by the app band filter. And additionally, you can filter for SR. I said SR is referred to surface reflectance, and you can still access and use legacy image type via safe search. And also, just to highlight, you will be prompted to update your legacy safe search to change it to PS Sim item type. This is a screenshot of updates to GIS integration after the Planet Scope March 1st release, where as you can see in this image here, now we have Planet Scope Scene. Previously, we have Planet Scope 3 bands, Planet Scope 4 bands. Now we remove those and we just put Planet Scope Scene. And here, the additional filter, a search filter that you can use where you can filter to search image near infrared and also to include the additional 4 bands. Okay, that's all from me. If you require more information, you may find us here. You can refer to our official Planet website. You can follow us at our LinkedIn. And next, I'm going to move I'm going to. We are going to the next speaker, Kevin. We're going to talk about the Esri platform. Thank you.
Thanks, Bonjour. Hi, I'm Kevin, Senior GIS Consultant of Esri China, Hong Kong. In the coming 30 minutes, I will briefly introduce our company, Esri China, Hong Kong. Then we will focus on the key imagery capability in our ArcGIS platform, which could facilitate with Planet satellite imagery products. Then our colleague, April and Felix, will demonstrate a live demo showcase the real application of Planet imagery in Hong Kong. If you have any question or query afterward, please feel free to leave it in the chat box and we will answer you in the Q&A section. Esri China Hong Kong Limited is a home-growth IT company with 100 staff providing state-of-art GIS and comprehensive mapping solution in Hong Kong and Macau since 1997. We specialize in GIS and mapping solution. We are not only deliver Esri GIS platform, but also we have over half of staff provide GIS and IT professional service for the implementation and other customized application setup and configuration of the GIS product in the environment. We also provide instructor need professional training to clients who want to use our software on their application if needed. GIS integrate many different kinds of data layers using spatial location. GIS data includes imagery, features, and base map linked to spreadsheet and tables. Spatial analysis let you elevate suitable and capability, estimate and predict, interpret and understand which leading news perspective to your insight and decision making. ArcGIS supports 3 fundamental systems: a system of record for transactional data management, a system of insight for analytics, and a system of engagement through apps and maps that connect people to the organization's work and help them communicate and share information. GIS is advancing and fusing with other advanced technologies, including BIM, IoT, big data modeling, AI, machine learning, and drone technology. We are integrating every type and format of data and making them directly available as service. Tabular data, unstructured data, real-time data, vector data, raster data, imagery data, and making it available as ready-to-use information in the form of web app and creating insights. Imagery and remote sensing are extremely useful for enriching GIS. It comes in many different types, and it is able to show both large and small area in varying level of detail. This makes it versatile and a wide variety of different GIS projects, and as such, it is a common type of data for GIS projects, enhancing your ability to understand the planet and the problem you face by putting them massive data volume to work using powerful image mapping. Oriented imagery, motion imagery, geospatial analytics, geospatial artificial intelligence, GAI, and modeling tools. ArcGIS empower you to derive richer business insight with visible deployment options for managing, analyzing, visualizing, and share your image and raster data. I would like to give a very brief overview of the 5 key imagery capabilities of ArcGIS. This diagram summarizes how ArcGIS is a comprehensive imagery platform. Let's start on the first capability of image management. The image management capability provides the extensive tools to create and manage set data set in ArcGIS Pro. These tools search data source to extract required metadata. They also make it possible to define any processing to be applied to transform or modify the imagery for raster from raw pixel to interpretable products. Use the raster and knitted capability to image server to scale up processing for very large collection of imagery and digital processing over multiple machines for a very rapid of mosaic and digital terrain model creation. Auto mapping capability are included in ArcGIS Pro, but also scale on the ArcGIS image server. Use the raster and knitted capability of image server to scale up processing for very large collection of imagery and digital processing over multiple machines for very rapid of mosaic and digital terrain model creation. Already imagery is a capability within ArcGIS that provide user the ability to manage, visualize, exploit, and analyze many types of imagery, including street view, 360 drone, aerial, video, and terrain image. As the imagery need to your organization growth, the more important proper imagery management becomes very important. All this content need to be managed, and if you have been using imagery in ArcGIS, you probably know that the mosaic data set is the primary data model for managing imagery. So mosaic data sets can be created to reference many types of imagery, while the mosaic data set knows where all the files are and maintain all the metadata associated with those files. The modern imagery user just wants to work with the pixel that cover their area of interest, and it doesn't matter if this pixel comes from one image or 100 images. All the visualization and processing functions you can run on a single machine can also be applied to mosaic dataset, saving consideration processing time. We support of nearly all raster file format, including TIFF, imagery, net, CDF, etc. Raster type and raster products to support commercial or customer sensor. We use mosaic dataset create and reference many types of imagery, so we can maintain image quality. We support for many types of imagery and frame. Let's keep on next activity, ArcGIS on map production. The map production capability focus on the tools to generate derived product from imagery such as orthomosaic, DTM, and 3D mesh. For the map production capability, where we provide a range of the application viewing the prepared, bringing raw imagery into an accurate mapping environment. Our customer work with imaging sensor of these 4 types. Let's look at the option for working with these different image source. Map production tools in ArcGIS are auto mapping tools within ArcGIS Pro. Auto mapping is not a separate product or extension and is available to all users of ArcGIS Pro with an advanced license. Auto mapping uses the mosaic data set to manage the raw data and enable generation of 2D and 3D derived products such as DDM, orthomosaic, and digital aeration model. For those organizations that deploy ArcGIS Enterprise with image server, we provide a built-in capability called AutoMaker for upload and processing drone images as a subset of auto mapping. For those organizations that have deployed ArcGIS Enterprise with image server, we provide a built-in capability called AutoMaker for upload and processing drone images. Let's keep on next capability, ArcGIS Analyst and AI. The ArcGIS Analyst AI capability provides the tools to extract information from imagery. This includes a wide range of machine learning and deep learning tools, change detection, etc. For the extraction of the location-based information from imagery, including classification, object detection, and object identification using machine learning, ArcGIS Pro include complete image classification workflow using pixel or object-based image classification by machine learning algorithm, including maximum likelihood, random forest, and support vector machine. ArcGIS Pro also include tools and interface for training and integrating with deep learning tools such as TensorFlow, CNK, PyTorch. This enables organizations to create data set to train the most appropriate deep learning algorithm. The algorithm can then be applied using the inference engine to identify, label, classify large collection of images. The result is now a new raster or featured data set that can input to other spatial analysts. Let's keep on the next capability of visualization and exploitation. The visualization and exploitation capability are the wide range of tools to enable human interpretation of the image and include many types of interactive imagery and the resulting information product. ArcGIS Pro, especially with the ArcGIS Image Analysis extension, provide a high optimized spatial desktop environment for integrated imagery with all forms of spatial data, both in 2D and 3D. ArcGIS provide tools for building configuration web app application for working with imagery. No programming required. The imaging widget designed for web app builder for ArcGIS, as well as configuration app campaign designed to support common imagery customized workflow. The developer also can use ArcGIS API to fully customize, such as application or building customized application from scratch. For image exploitation, compression, and observation management, ArcGIS Xcuber, a web-based integrated imagery and GIS experience, allow users to search on the web for imagery, bring it up, and then exploit the imagery. Let's keep on the next capability of content. As we also work closely with a number of partners, including Planet, Digital Global, Airbus, etc., to provide subscription access of imagery content. Partner provide imagery as a dynamic image service that can be accessed directly. Our colleague, April and Felix, will demonstrate a live demo showcase the real application for managing and using Planet imagery in ArcGIS Pro. So please.
Thank you, Kelvin. Hello, everyone. I will demonstrate how to use ArcGIS to access, manage, and analyze planet imagery. With ArcGIS Pro planet imagery add-in, we can unlock the power of frequent and high-resolution planet imagery into the ArcGIS workflow. Just select the account icon to log into your Planet account, and we can use the image search button to search for available planet imageries. First, because we want to discover imageries that are inside the boundary of Hong Kong, so we will first zoom to the target location on the map, and then use it as our area of interest. Selecting this as the current visible extent as our AOI, and we can also refine our searching results using the filters. Here, we can choose different time range, select different resolution of imagery ranging from Skyset, Planscope to Sentinel or Landsat. We can also select which spectral bands will be included in our searching results. Some thresholds such as area coverage, cloud coverage can also be adjusted here. Once we are satisfied of our settings, we can go back and search for the imagery that satisfy our settings. We can locate our desired imagery from the list, select them, and then place an order. Once the order is finished processing, we can click the download button to download them into our local disk. Using ArcGIS Pro, we can easily add the imagery downloaded to our disk to the map. However, instead of managing them one at a time, we will use Mosaic dataset for batch control. Mosaic dataset can be created easily inside a geo database by just simply define the name and the coordinate system. The Mosaic dataset can be created in just few seconds. After the Mosaic dataset has been created, we will load the images to them. Since our images are all stored in the folder, so we will use the folder as our input data. The Mosaic dataset is like a photo album, which is not storing the actual images on disk, but to create a reference to the images. Mosaic dataset contains three elements. The boundary is the extent of all the imageries of the Mosaic dataset. Footprint contains the outline of each images, and the image element controls the overall rendering. Using Mosaic dataset, we can easily enhance the visualization of all the imageries. For example, we can change the band combination. We can also adjust the brightness, contrast, or gamma values to enhance the visualization. There are many stretch types available for us to select from to further enhance the visualized results. More importantly, using mosaic dataset, we can apply geoprocessing for image analysis. Raster functions are operations that can be applied to raster data on the fly as the data is accessed or viewed. ArcGIS Pro has provided mainly out-of-the-box raster functions. They can be used for geometric correction, data management, analysis, or surface management. Imagine that we want to narrow down our analysis area by both sides of the Victoria Harbour. First, we have loaded the 18 district polygon in the map. And then we can select the polygons that are from either side of the harbour. Then we go to the raster function and search for clip function. Using the clip function, we can extract our mosaic data sets to be within the boundary of the selected polygons. By clicking this create new layer, results layer will be added on the fly in the map content. This result is not stored inside the disk, but just for our visualization and analysis. We can see that the imagery has been extracted just within the shape of our selected polygons. Measuring how the world changed is a fundamental type of analysis that affects nearly everyone. How much has been gained, how much has been lost. This kind of change can be measured using spatial analysis tools in ArcGIS and with planted imageries. It has been reported that at the Grass Island, which is also called Tap-Moon Island in Hong Kong, is running out of grass in recent years due to the increasing camping activities. Let's find out if this is true and try to locate the area where the grass are getting thinner. We have obtained two imageries from Planet. One is in 2016, the other is in 2022. To measure the amount of greeniness, we will use NDVI, which is also called Normalized Different Vegetation Index. ArcGIS Pro has provided mainly a ready-to-use index. We just easily call the index from the index menu, select NDVI, and then choose the near-infrared band and the red band. The NDVI values will be calculated for either of the images. We can use the swipe tool for image comparison. However, using our human eye to identify the difference between these two datasets is quite difficult. Instead, we will use another function called difference process. The difference process is like applying a minus calculation. The negative result represents the decrease of grass in 2022 compared with 2016. However, are all the negative results statistically significant, or are they just fall inside the normal floating interval? Charting function provided by ArcGIS Pro can help us to identify the meaningful change. So we will create a histogram chart on the difference layer. We can see that the values of this difference layer apply to the normal distribution. The mean and the standard deviation values has been calculated by ArcGIS Pro. We can see that for the numbers outside of the standard deviation range, they are representing the most severe reduction of grass in the past 5 years. Using this threshold, we will modify the display of the difference layer. We'll change the symbology type to classify. And then reclassify the classes from 5 to 3. Then we will alter the upper values of the first class and the second class based on the threshold we just identified from the standard deviation. Different colors will also be assigned to the three classes. Now, in this case, we can see that the purple areas on the map represent the areas where grass has declined significantly in the past 5 years. In the next session, Phyllis will demonstrate how to use AI function of ArcGIS Pro for object detection.
Hello everyone, I'm Phyllis. I will do the object detection task on Hong Kong buildings. You can see that I have two imagery from Planet. One is the Mayfu Central Estate and the other is the Huangpu Garden. For the Mayfu Estate, I will use it for training, and for the Huangpu Garden map, I will use it for testing the trained model. Let's have a quick view on what we can get. This is the final result. You can see that the buildings are marked according to their shape, and the model we use here is the mass RCNN. Let's begin the workflow. So start from the Mayfu imagery. On the top, take the imagery ribbon and select label object for deep learning. You can right-click the new schema and add new task. This is the buildings from Mayfu. And here, we only detect one type of objects, buildings. Say, we put one here. And we use red for visualizing the mass more easily. To label it, it is very simple. Just take draw by polygon and go back to the red. To finish the drawing, we can click F2 and we finish drawing one building. And this is the second building. And we use the label, we can save it to our Geo database. In fact, for my training, I have used 16 buildings. For this building, the internal patterns are different. We use the labels by choosing the folder and choose the previously stored building Mayfu 16. These buildings have different colors and the internal part is a bit different. Some have more silvery parts there and some has not. So sampling uniformly can help the detection. The next step, we will export images. This is the output folder where the image is stored. It will be stored under a labeled object folder. under the project directory. For the tail size, this means the size of the image chip's output, export. For example, if it is 256, an image chip of 256 times 256 pixels containing the labels will be exported. For the stride, it refers to the movements in taking exporting image. For example, if it is half of the tail size, not only one tails will be exported. When I export these labels, another labels is generated by moving to the right by 128 pixels. Similarly, there will be two more labels generated by moving downwards by 128 pixels. As you expect, buildings in Hong Kong is not always tilted in one direction. In order to generalize the result, we can use the rotation angle parameter here to generate more buildings in other direction. In my training, 45 degrees is enough, and it will generate some buildings in right upwards and some are tilted. For the last thing, since we are going to use the mass RCNN model, the metadata format, we will change it to RCNN mass. And click Run. We can have the labels generated. Let's see on the files what we can get in the export images. Originally, we have 16 buildings. However, after the rotation angles parameter and the stride parameters involved, we have totally 449 images generated. If your sample size is small, you can use this technique to increase the training samples. Let's continue. We will go to step B, train the model. We use a tool called train deep learning model. And then we select the exported image chips file folder. The suggested model tells us that we can use mass RCNN. It's coherent to the metadata format we selected previously for the labels. There is a chip size of 224. This is the best for the mass RCNN. And there will be a resize automatically done if it is unmatched by the previous tail size, and we can leave it as 224. The learning rate will be calculated automatically. For the validation percentage, it means 90. If it is 10%, it means among the 449 images, 90% are actually used to train and 10% used for validation and evaluate the model. We can start training and it takes about 5 minutes. Here is the trained result. We can see that what learning rate is used. And also, this graph suggests that the loss for train training set and the validation set converge. That means the model is okay. And if you see some divergence or some gaps between them, then you may need to include more training samples or you need to change the architecture. It also tells us the predicted result compared to the ground truth. You may see here many colors overlap together. All of these are the detected mass of different size. For the final steps, I will use a geoprocessing tool called detect objects using deep learning, and just for the detecting buildings in Huangpu, just choose the Huangpu imagery, and then we choose back the model we generated. Choose the EMD file for the ArcGIS model definition file. And in order to view more results for our demo, I use the flexible 0.6. To prevent generating many mass overlapping, we will use enable the maximum suppression, and we use the ratios 0.1, which means that we only allow two detected mass having overlapping area of 10%. And check one, it takes about 1 minute for my model. And finally, I have generated the result here. And that's my presentation. I'll give it back to Kevin.
Thank you, April and Felix. We will now take some time for questions. Just a reminder to make sure your question is answered properly using the webinar software. Okay. Question coming. How many images can be in a mosaic data set? I think April can answer this question, please.
The documentation for ArcGIS does not specify a maximum number of images per mosaic data set can be stored. However, while you're working with a large amount of images to better enhance the performance, we recommend you to use source and derived mosaic data sets. It's like breaking a very complex task into a smaller tasks. So it's more easier to manage multiple sources and we can also assure the quality of image rendering.
Okay. Thank you, April. Okay, second question is, for the map production from Imagery, do you have any ArcGIS tools for drone imagery data capture? I think I can answer this question. Yes, SideScan for ArcGIS is a new Esri product that provides drone flight planning, fleet management, image processing, and analysis capability as software as a service. SideScan delivers a complete end-to-end solution for drone imaging project. User can plan and execute drone flight and manage flight data and their drone fleet to run safe and sufficient drone operations. Then generate 2D and 3D mapping and analytic products from drone imagery before publish drone mapping products to ArcGIS Online. Enterprise or Autodesk BIM 360. And the third question is there any minimum size required for Skyset tasking?
Okay, I can answer this. Yeah, I can answer this. Yes, we do have minimum AOI size requirement for Skyset tasking, which is minimum size is 25 square kilometer. Where for Skyset we can image as we can collect a big area, or if for a small area we can do what we call a point collect, where we need the coordinate leg long of the location, and we collect 5 by 5, which is around 35 square kilometers. So the minimum size for Skyset is 25 square kilometer. For this is for tasking. Yeah, thank you.
Thank you. The fourth question is, can the deep learning model trained through ArcGIS be shared? Felix, can you help to answer this question, please?
Okay. Yes. Actually, there are two ways to share the model. First, you can save it locally as a deep learning model package. Second, you can also publish it to an online account. In this case, we can do analysis on ArcGIS online using that model.
Okay, thank you, Felix. The fifth question is, can I use Mosaic dataset manage images stored in the cloud? April, can you help to answer this question, please?
Yes, we Mosaic dataset can also manage the images that are stored in the cloud, not physically stored in the disk. To do this, we can Esri provides different methods. The first one is called cloud storage connection file, also called for shorten is ACS. The other method is using a raster proxy files. This raster proxy file is just like a XML file, defining the path to the images stored in the cloud. And there are also other methods to reference the image on the cloud, which are VSL file handler, or we just using a file share is also possible. We just define the path to the files that store in the cloud, then the Mosaic dataset can actually manage those imageries. Thanks.
Thank you, April. Sixth question. What's the meaning of orient imagery? Oh, I think I can answer this question. Orient imagery is a capability within ArcGIS that provides a user the ability to manage, visualize, export, and analyze many types of imagery, such as street side, 360, drone, aerial, video, and traditional terrestrial images captured by many different cameras. The next question is, can I use Planet Trial to access Planet imagery in Esri Planet plugin? Brazil, can you help to answer this question, please?
Yeah, short answer is yes. If you already signed up for Planet trial account, you can try use the Planet Esri plugin, or if you already use Esri ArcGIS, you can just install the plugin, and then you can use your trial Planet account to access Planet imagery. Just I want to highlight for the trial Planet Planet account is only limited to the medium resolution, which is view only. There is no download. If you need to have some sample, you can reach out to us, either Planet, or you also can reach out to Esri Hong Kong for some sample.
Thank you, Bajra. Next question is, what are the GPU required for running deep learning tools? I think please help me to answer the question, please.
Okay, for the GPU, it is suggested from ArcGIS that the GPU has video RAM 8 GHz for running the training and inferencing deep learning model tools. In particular, if the deep learning tools is about detection and the classification, then 4 GB is minimum, but 8 GB is recommended.
Thank you, Felix. I think this is the last question. Yes. Can I save the raster function outputs? April, can you help to answer this question, please?
Well, actually, I'm not sure if I mentioned it during my talk. One of the benefit of raster function is that it saves the time to create and store the result on our disk. Because it's processing the data on the flight. However, if users would really like to store the result on disk for further analysis, yes, we can export the result of the raster functions to another function, another raster type in store in geodatabase or store in folder. And on the other hand, if you would like to have a result stored on disk, you can choose to use geoprocessing tools. For some raster function, they have corresponding geoprocessing tool. For example, if you run a hill-shaped raster function, actually there is another geoprocessing tool also called hill-shaped. So using a geoprocessing tool, we can actually physically specify the output location so that we can save the result on disk.
Thank you, April. Thank you, everyone. We appreciate you being here. We would like to know your point of view about our presentation. Please scan the QR code and fill in the survey 123 form. Thank you. Of course, for a more personalized discussion and more detail, please reach out to us on sales@esrichina.hk or sales@planet.com. Thanks again for joining us today, and we will see you all next time around. Bye-bye.
Thank you, everyone. Bye-bye.
Thank you, everyone.